Hello student, I am Gurmeet Singh and welcome to CREATA classes and also welcome to our 6th lecture on probability series. From this lecture onward, we are starting exercise 15.1. We have divided the exercise into total 3 parts, part 1, 2 and 3, and this is part 1. In this lecture, we will take down question number 1 to question number 10. For rest of the videos of the probability series, check out the link in the description. One important thing before coming to this exercise 15.1, my advice is that you also complete the theory video and the example question of the NCERT. The link to all those videos is given in the description. That is important because we have covered like the important concept in those videos. So that will be really helpful to you. So without taking any further time, let's start the lecture. Best of luck. The question number 1 is having 5 parts, that is 5 fill in the blank statement. Let's take one by one. The first part is the probability of an event E plus probability of event not E is equal to. We have covered the concept in the theory part, that is the probability of happening of the event plus the probability of not happening of the event is equal to 1. The answer of the question is 1. The theory lecture, the link is given in the description. We have already covered that. We have also seen that the probability of happening of the event head plus probability of not happening of the event head is equal to 1. And we have also used the concept in the case of dice where we have calculated the probability of not getting the number 1 when rolling the die. We have also covered the various questions in very detail. Refer the link in the description for understanding the concept in further detail. So the answer of this question is 1. Let's move to the next question. The probability of an event that cannot happen is dash. Such an event is called dash. We have learned the concept of range of probability, in which we have seen the range of probability is from 0 to 1. 0 is 0% probability, means the possibility of happening of that event is 0%, that is 0, which are basically known as impossible events. On the other side, the extreme range of probability is 1 or 100%. It means full surety of the event, also called the sure event. In this question, the question framer is asking the probability of an event that cannot happen. Then the answer is 0, that is extreme left hand side. And further, it is asking such an event is called, it is called impossible events. Got it? Very simple question. The next question is the probability of an event that is certain to happen is dash. Such an event is called dash. So the probability of an event that is certain to happen is 1. That is 100% probability, extreme right hand side 100% or 1. And what we call such event? We call such event as sure events. Got it? Very simple question. Second and third questions are basically the same question. Fourth, the sum of the probabilities of all the elementary events of the experiment is the same concept we have covered in the theory. If we add the probability of all the events within an experiment, then the sum will be 1. We have done this. If we add the probability of all the events, then it will be 1. Various examples we have taken. For example, in case of coin, we are getting two outputs, head and tail. If we add the probability of head and tail, we get 1 by 2 plus 1 by 2, that is 1. Similarly, in the dice we have seen, if we add the probability of all the events 1 by 6 plus 1 by 6 up to the last term, we will get 1. So the question is asking the same, that is if we add the probability of all the events, it will be 1. The last part of the question, the probability of an event is greater than or equal to dash and less than or equal to dash. So basically this question is combination of question number 2 and 3, that is what is the range of probability. We have seen the range is from 0 to 1, that is probability can lie only between 0 to 1, that is 0% to 100%. So it will be 0 and 1. If you have not done the theory, my advice is just go to the description and complete the theory as well as question. That will be really helpful to you. So moving further, let's move to question number 2. Which of the following experiments have equally likely outcomes? Explain. 4 conditions are given. We have to find which of the following experiment or the cases are equally likely outcome. Firstly, let's understand what is this equally likely outcome. It means that whenever we do the experiment, we are getting some of the events or the output. When the possibility or the probability of all those events is equal, then we call those events or those experiments as equally likely outcome. That is, all the outputs are equal. For example, if we toss the coin, we are getting head and tail. We are getting only 2 outputs, and we have seen the probability of getting the head is 1 by 2 and the probability of getting the tail is 1 by 2. Here the probability of both the event is equal. It means we can say tossing the coin and getting the head and tail are equally likely outcome. Got it? Similarly, in the case of dice, we are getting 1 by 6 in all the 6 output. It means that rolling the dice and getting the 6 outputs are equally likely outcome. Got it? Now we are having 4 cases. We have to analyze the case and we have to tell whether the outputs or the events will be equal or not. Let's take the first case. A driver attempts to start a car. The car starts or does not start. So the experiment is the driver is attempting to start the car and the outputs are the car will start or not. Here this driver is attempting to start the car. So whenever you try to start the car or any of the vehicle, the possibility of starting of that vehicle is much larger as compared to not starting of the vehicle. Assume you are having a car or any of the vehicle at your home. You start that vehicle and what is the possibility that it will start? Yes, maximum times the vehicle or the car will start. It means starting of the car and not starting of the car are not equal. Let's assume we are having any old car and it is standing there for the last 1 year or 2 years or more than that. What is the possibility of starting of that car? The possibility of the starting of the car, the old car, is very less as compared to starting of the car. So we can say in the first case both the outputs or both the events are not equal to each other. So we can say this case is not equally likely outcome. Got it? Very simple question, just a scenario based case, and just we have to identify whether the outputs are equal or not. Let's take the second case. The player attempts to shoot a basketball. She or he shoots or misses the shot. Here the players are playing the basketball and they are shooting the basket. So what is the possibility that they will be able to shoot the basket or not? If the player is very experienced, then the possibility of shooting the basket or getting the point is much higher as compared to not getting that point. And if the player is very new, the possibility of shooting of that basket is very low. It means that we can say the shooting of the shot or missing of the shot are not equal to each other. The possibility of shooting and the possibility of missing are not equal to each other. If the player is experienced, the possibility of shooting will be higher, and if the player is not so much experienced, then the possibility of not shooting will be higher. Again, this case is not equally likely outcome case. Let's move to the next case. A trial is made to answer a true-false question. The answer is right or wrong. So in this question, a trial is made to answer a true-false question. We are doing the trial means the possibility of getting the answer right or wrong is 50-50%. If we know sure shot what is the answer, we can say the probability of getting the answer as right is much higher as compared to getting it wrong. But here we are doing the trial. It means that the possibility of getting the answer right or wrong is equal, that is 50-50%. So we can say this case is the case of equally likely outcome. Got it? Last part, a baby is born. It is a boy or a girl. Here the possibility of getting the boy or a girl is 50-50%. So we can say the fourth case is also the case of equally likely outcome. The first two cases is not satisfying the condition. The third and the fourth case are satisfying the condition. Let's move to the next question. Why is tossing a coin considered to be fair way of deciding which team should get the ball at the beginning of the football game? In the beginning of the football game, the toss is done and the question is asking why this toss is done or why this toss is a fair way of deciding which team will get the ball. The answer is that because when we toss the coin, we are getting the two outputs, that is head and tail, and the possibility of getting both the outputs are equal, 50-50%. Probability of getting the head is 1/2, the probability of getting the tail is 1/2. That is 0.5 and 0.5, that is 50% and 50%. So the tossing of the coin is the case of equal likely outcome. So we can say it is a fair way to decide which team will get the ball because the output are 50-50%. No biasness is there, either we get head or tail, that is 50-50% case will be there. No possibility of cheating will be there, so we choose the coin. So the first three questions are very simple, just a scenario based question or one word question. Let's move to question number 4. Here we will start using the formula and the fundamentals. The question is, which of the following cannot be the probability of the event? 4 cases are given, 2/3, -1.5, 15% and 0.7. We have to tell which of the 4 cases are not the probability of any event. How we will approach this question? We will use the fundamental of range of the probability. We know the range of the probability is from 0 to 1. All the cases which lies between 0 to 1 will lie in the range of probability, and all those cases which are beyond the range of 0 to 1 will not be the case of probability. Let's try to plot all the 4 cases on this graphics of the range 0 to 1. The first case 2/3, it is basically 0.6, so it will lie somewhere around here. So we can say the first case is within the range of the probability. Let's go to the second case, -1.5. -1.5 is going beyond the range of 0 to 1. That is, it will lie somewhere here beyond the 0 because it is in negative. So this case is not the case of probability. Let's move to third case, 15%. The range is from 0 to 1, that is 0% to 100%. In terms of percentage, 15% will lie somewhere here. It means it is the case of probability. The fourth one, 0.7, it will lie somewhere here, that is around 70%. So we can say the fourth case is also the case of probability. First, third and fourth are the case of probability, and the second is not because it is in negative and it is not in the range of 0 to 1. So we have done the question number 4. Let's move to question number 5. The question is, if PE is 0.05, what is the probability of not E? We have done the concept, that is probability of happening of the event plus the probability of not happening of the event is equal to 1. The first case is given, that is PE is given, which is 0.05. We have to find P not E. Let's put the value. Very simple question. We got the answer as 0.95. The initial questions are very easy. As we proceed with the question, the toughness or the hardness of the question will increase. Let's move to the sixth question. A bag contains lemon flavor candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out? First, an orange flavored candy. Second, a lemon flavored candy. Let's try to understand this question. A bag contains only the lemon flavored candies. Means it is having no other candies, only lemon flavor candies are given. So what is the probability of getting an orange flavored candy? It is only having the lemon flavored candy, so we cannot get the orange flavor candy. So the probability of getting the orange flavor candy is 0. We are not having any orange flavor candy, then the event is an impossible event. So the answer is 0, that is 0%. And what is the probability of getting a lemon flavor candy? It is 1 or 100%. The bag is only having the lemon flavored candy, so the possibility of getting the lemon flavor candy out of the bag is 100%. That is sure event. Again, a very simple question. We can also use the formula, but we are not using the formula. We are trying to use the basic theory only to solve the question. Here in this question, the orange flavor candy is an impossible event, so that is 0. And the lemon flavored candy case is sure event, that is 100% sure. Let's move to the next question. The question is, it is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? Let's analyze the question. In a group of 3 students, this is a group of 3 students, the probability of 2 students not having the same birthday is 0.992. The question is asking what will be the probability that the 2 students have the same birthday. We have seen the probability of happening of the event plus the probability of not happening of the event is equal to 1. Here the event is 2 students having the same birthday. So can we say the probability of the 2 students having the same birthday plus the probability of 2 students not having the same birthday is equal to 1? Yes, we can use the fundamental and we can say so. One condition is given, that is 0.992, the probability of 2 students not having the same birthday. Let's put the value. We got our answer as 0.008. Again, a simple question based on the direct formula. Let's move to the next question. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is first red and second not red? Here the question is having 2 parts. Firstly, let's analyze the question. In the question, a bag is given which is having some balls. The balls are 3 red balls and 5 black balls. A single ball is drawn at random from the bag, and we have to calculate what is the probability that the ball is red and in the second case not red. So we have understood the question. Let's try to use the formula. This is a formula of probability. Let's start with the denominator, that is total outcomes. Here the total outcome will be 3 red ball and 5 black ball. That will be 3 plus 5, that is 8 total outcomes will be there. So we will get 8 in the denominator. 3 red and 5 black ball, the total is 8. So we got 8 in the denominator. Further, let's move to the numerator. What are the total favorable cases when we have to get the red ball? The favorable condition to red ball is 3 red balls. We have 3 red balls, so in the numerator the favorable condition will be 3 red balls. So we got 3 in the numerator and 8 in the denominator. We got the probability of red ball as 3 by 8. Got it? Very simple. Let's move to the second part. We can approach the second part in 2 different ways. In the second part, we have to calculate the probability of not red ball. We can use the formula, that is PE plus PE bar is equal to 1. That is probability of happening of the event plus the probability of not happening of the event is equal to 1. We can use this fundamental to solve the question. We got probability of red ball plus probability of not red ball is equal to 1. And just now we have calculated the probability of red ball as 3 by 8. Let's put the value. We got our answer as 5 by 8. That is probability of not getting the red ball. We can also approach the second part in different way. The bag is having 3 red ball and 5 black ball. What is the probability of not having the red ball? That will be the probability of black ball. No red ball means it is black ball because we are having only red and black balls in the bag. So the output is not red, it means the output is black. So we can calculate the probability of black ball as 5 black balls in the numerator, that is the favorable condition, and total 8 balls, that is 3 red and 5 black in the denominator. So we have got 5 by 8. We can approach the second part in 2 different ways, and you should know all the ways how to approach the question because that is important in the mid of the exam to solve any difficult type of question. Okay, we have done this question. Let's move to next question. The question is, a box contains 5 red marbles, 8 white marbles and 4 green marbles. One marble is drawn out of the box at random. What is the probability that the marble taken out will be first red, second white and third not green? Firstly, let's observe the question. In the question, a box is given and the box is having some marbles. It is having 5 red marbles, 8 white marbles and 4 green marbles. And one marble is taken out of the box at random, and we have to calculate the probability that the taken out marble is either red, either white or either not green. Just focus here the word not green is given. So the question framer is slightly want to trick the question. Let's see how we can approach all the 3 parts. So we have observed the question, we have visualized the question. Next, let's take the formula of the probability. As usual, we will start from the denominator. In the denominator, what are the total outcome? Here the total outcome will be 5 red marbles, 8 white marbles and 4 green marbles. So we got 5 plus 8 plus 4, that is total 17 marbles in the denominator. What will be in the numerator? In the first case, we have to calculate the probability of red marble. So in the numerator, the favorable condition will be 5 red marbles. So we got 5 in the numerator and 17 in the denominator. We got the probability of red marble as 5 by 17. In the second part, we have to calculate the probability of white marble. Here we will use the same formula. In the denominator, the total number of marbles will be there, that is 5 red, 8 white and 4 green marbles, that is 17. In the numerator, the favorable condition, that is 8 white marbles are there, that will come in the numerator. So on solving, we got our answer as 8 by 17. Got it? 8 white marbles and total 17 marbles. Let's move to the third part. Third part is slightly tricky because here not word is used. The question framer is slightly want to trick the question, so he or she has added the word not. So how to approach the question of not green marble? We can do in 2 ways. First, we can calculate the probability of green marble, and we can use the formula of probability of green marble plus probability of not green marble is equal to 1. The second approach is that we have to identify what is not green. If we take one marble out of the bag, then what is the possibility that marble is not green? It means that that marble is either red or white. If we get the red or white marble out of the box, it means that it is not green marble. So what is the probability of getting the red and the white marble out of the box? That will be equal to 8 plus 5 upon 17. 8 white marble and 5 red marble. So we got our answer as 13 by 17. Got it? We can also calculate the probability of green marble as 4 by 17, and we can also use this formula and calculate the probability as 1 minus 4 by 17. That will also come as 13 by 17. So you should know all the approaches. We have done with this question. Let's move to the next question. A piggy bank contains 150 paisa coins, 50 rupees 1 coins, 20 rupees 2 coins, and 10 rupees 5 coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin, first case, will be a 50 paisa coin, second, will not be a rupees 5 coin? Firstly, let's observe the question. A piggy bank is given, so this is a piggy bank, and the piggy bank is having some of the coins, which are 50 paisa coin, rupees 1 coin, rupees 2 coin, and rupees 5 coin. The number of 50 paisa coin is 100, number of rupees 1 coin is 50, rupees 2 coin is 20, and rupees 5 coin is 10. So all these coins are inside this piggy bank. If we turn this piggy bank upside down, one coin will fall from this piggy bank. What is the probability that the fallen coin is 50 paisa coin? So we have understood the question. Let's use the formula of probability. We will start with the denominator. In the denominator, it will be the total outcome. That will be equal to all the coins in the piggy bank. So we have 150 paisa coin, 50 rupees 1 coin, 20 rupees 2 coin, and 10 rupees 5 coin. All these coin will come in the denominator. That will add up to 180 coins. In the numerator, the favorable outcome of 50 paisa coin will be there. So we are having 150 paisa coin. That is the favorable condition to our probability. So these 50 coins will come in the numerator. We have 150 paisa coin. So these are the favorable condition, that is 150 paisa coins. So in the numerator we will have 100 coins. So we got 100 coins in the numerator and 180 coins in the denominator. We got our answer as 5 by 9. Got it? In the second part, we have to calculate the probability that it will not be a rupees 5 coin. Again, we can use the two approach. In the first approach, we can calculate the probability of rupees 5 coin, and we can use this formula. We can easily solve the probability of not rupees 5 coin, or we can use the different approach, that is in which cases it will not be a rupees 5 coin. So in which cases it will not be rupees 5 coin? When it is either a 50 paisa coin or rupees 1 coin or rupees 2 coin. If we got 50 paisa, rupees 1 or rupees 2 coin, then it means that it is not rupees 5 coin, because we are having only 4 cases. So let's try this. In the denominator, again the total 180 coins will be there, and in the numerator it will be 50 paisa coins, rupees 1 coins, and rupees 2 coins. That will be 150 paisa, 50 rupees 1 coin, and 20 rupees 2 coin. So we got the addition as 170 and we got 180 in the denominator. Our answer is 17 by 18. Got it? We could have done this question if we have calculated the probability of rupees 5 coin. That will be 10 by 180. Why? Because we are having 10 rupees 5 coin. That will be the favorable condition to rupees 5 coin, which will come in the numerator. And in the denominator we got 180 total coins. So that is the probability of getting rupees 5 coin, and we have to calculate not rupees 5 coin. We can use this formula and we can calculate the probability as 17 by 18. We can use any of the approach, but you should know all the approaches. So that's it for this lecture. Hope you have enjoyed our unique way of teaching using animation and the graphics, the visual learning tools. So this is the part 1 of the exercise 15.1. In the next lecture, we will take down the part 2. That is question number 11 to question number 20. So thank you very much. Bye for now and have a great day. See you in the next video. Bye.